All right. So, continuing on. Hold on. Continuing on. So, again, they didn't ask us for the radius of convergence or interval of convergence, but how do we find that? Well, we will take our r. We know our r absolute value has to be less than 1. So what is our r in this situation? Negative x over 2, right? Mm-hmm. So that's what we do. Now, absolute value of that is going to give us a positive, and then we will multiply out the 2. So what is our radius of convergence? It is 2. Okay. What is our interval of convergence? Negative 2 to 2. We don't have to test the endpoints since we're using an infinite geometric series. Okay. So now we practiced rewriting some of these expressions, these expressions, in the form of a power series. We learned how to factor things out and kind of manipulate the denominator, make sure our numerator is 1, and then work it out so we can generate what our r is, and then rewrite it in this summation notation, right? Okay, now we are going to take the derivative and antiderivative of power series. Yes. Okay, so here we go. Differentiation and integration of power series. So this right here is a theorem. It says if the power series Cn times the quantity x minus a to the n has a radius of convergence of r greater than 0, then the function f defined by this which is basically the expansion of this power series, is differentiable and therefore continuous on the open interval, and this is your interval of convergence. So now let's suppose we want to take the derivative. So let's say I want to take f prime of x. What is f prime of x? Well, if I look at just the expansion of f prime and I start taking the derivative of every single one of these terms, well, the first one is going to be 0, right? Because that is a constant. Plus, the next one is just going to be c1, because the derivative of that is just going to be 1 times c1. Plus, then here, this is going to be 2, coefficient 2, times the quantity x minus a to the first power. Plus 3, coefficient 3, times the quantity x minus a to the second power. Plus, and we would keep doing, we would just use the power rule and we make sure that we keep our coefficients, right? This is the same thing as us taking the derivative with respect to x of this sum. N equal to 0 to infinity, Cn x minus a to the n. Which is equivalent to us also having this sum, n equal to 0 to infinity, of the derivative with respect to x of each term in my summation. Because that is essentially what I just did. I took the derivative of every single one, and now we summed them all up. That's what we just did. Which, if I want to just write this as a sum, then this would be take the derivative of this term. So what is the derivative of this term? Well, we keep the coefficient. we bring down the exponent, and then we subtract 1 from it. So it's going to be n, when I bring down the exponent, times the coefficient, x minus a to the n minus 1. N equal to infinity. Now at this point, we need to think twice. Is it n equal to 0 or n equal to 1? Well, we know here, when I did this expression here, this went to 0. Goodbye. So what is my first one? 1, right? Not only that, when I get to the next one, if n were 2, if n was 2, how do I get this 1? I have to have subtracted, right? So what is my first term? N equal to 1. Okay? Yeah. So guys, that is the derivative of this f prime, which is equal to, of this function f, which is equal to this power series, right? Okay? So now let's do the integral of it. So now if I do integral of f of x dx, what is that equal to? Well, I want to find the antiderivative for every single one of those, right? Okay, so the first one, if I'm going to do this, I'm going to have c naught, x minus a plus c1 x minus a, increase my power, divide by that power, plus, keep my coefficient, increase my power, divide by that power, plus plus c, which this has an infinite number of terms, so I won't be able to write my c over here, so I'm going to squeeze it in right there. I should have left more room. Which I can write this as c plus the integral of the sum n equal to 0 to infinity, cn x minus a to the n dx. Which, what did this generate for us? This generated c plus the sum. And basically what we're going to do, is take the antiderivative of this term. So I keep my coefficient. What do? We raise the power. So we do n plus 1 divided by n plus 1. Oh, I didn't show you that. There you go. Bless you. N plus 1 divided by n plus 1. Now let's just double check. What does our n have to equal? So I go back to this. I've got my c. This n is 0. And if it was 0 and I put plus 1, that'll get me to the first power, right? Okay. If my n was 1, then that's 1. And if I put 1 there, that'll get me to my second power divided by 2. So that means we have to start off at n equal to 0 to infinity. Now the last thing is, if the radius of convergence for this power series is r, whatever this r is, then the radius of convergence for this guy is r. This is a new power series, right? And this also is a new power series. Its radius of convergence is